If you're watching this, you probably already know about machine learning is and you're excited about it. You know that it's a set of techniques that involves training algorithms with data rather than developing handcrafted solutions. You may also know that there are different kinds of machine learning solutions. So there's a classifier which is used to say what type of thing this data is, e.g. this is a picture of a dog, or a regressor which estimates a numeric value such as the price of this 3-bedroom house is £300,000. And there are unsupervised models, such as generative models like GPT-3, which can be used to generate novel text, to artificially write song lyrics, for example. You'll certainly know that lots of organisations are using them for lots of different purposes, and probably you're excited or have been using them yourself. These solutions are powered by algorithms, and it can be very tempting to focus solely on these. After all, they are very clever. They require deep expertise and insight, and in some cases they really seem to perform miracles. But if you only do this, you'll arrive at a point where you have an algorithm which has, hopefully, been tested on good data, but is not connected with your day-to-day business activities, and you've not gained any business value from them. Obtaining this business value requires more than just a focus on algorithm development. It needs engineering to support the algorithm development part of the process, and to integrate the machine learning solution into your daily operations. These activities are what we refer to as MLOPs. Before I go on, sometimes I'll use the word algorithm and sometimes I'll use the word model. There are some subtle differences between the two, but generally I'll use them interchangeably, so don't worry about that. Creating a solution which uses machine learning is a dual-track process, in which data scientists work on historical data to create algorithms, and machine learning engineering teams provide access to the data sources and then integrate the model into operational systems and data flows. Let's look at what needs to happen to develop and use a machine learning algorithm in operations. You'll typically go through the following steps. There's an initial development of the algorithm, there's some integration and deployment. You then operate it and monitor its performance, and you'll want to update the model. Let's start with the first of these, which is developing the model. This is the domain of the data scientists. Typically, they clarify and understand what the need is, and they will also have to identify or create ground truth data sets. These are sets of historical data which contains the input data paired with what the expected output should be. For example, for our algorithm to detect pictures of dogs, it is one thing to have 100,000 images, but they are only useful in a machine learning context if each image is also labelled with whether it has a dog in it or not. That is what we call a ground truth data set. The data scientists will explore the data and prototype different machine learning approaches. So they'll try different algorithms, maybe doing some transformations of the input data. This is what we call feature engineering. And they will evaluate these prototypes against holdout data sets. So these are test sets of data which the algorithm has not used in the training. This way they can gain an understanding of its performance against unseen data. And this will give us an idea of how it's going to work in real life. Hopefully, at some point, they'll create a model which meets the required performance criteria. Maybe it can detect dogs in images 95% of the time. And now we want to integrate it into the business. There are a variety of ways you can integrate with your business, and the right option will depend on the downstream services or users. In a modern architecture, for example, a standalone microservice may well be the best way to make it available to consuming applications. But depending on the context, other options might be better, such as for a streaming event-driven architecture, an in-memory model might be a better choice. Data scientists often develop using notebooks. These are a mixture of code, notes and visualizations, which are great for exploring and prototyping, but are unlikely to be the way you want to deploy the algorithm. You'll need to convert the prototype into your target format, a microservice, in-memory model, whatever it is, and you'll need a mechanism to promote the approved versions of the algorithm from the development environment into the operational environment. Now it is in operation, you want to make sure it is working and performing as it should. as well as monitoring the same things you would do for any piece of software, so that it is running, that it is scaling to meet demand, and so on, you will also want to monitor how accurate it is when deployed in practice. For some use cases, this is straightforward, and you're already collecting this data. But for others, you will need to collect the ground truth data at least for a sample of your outputs. In most cases, you will want to update the model on a regular basis, either because new data is available or because your data scientists have continued prototyping and have developed better models. Sometimes the new models require additional data, and so the interfaces to the model will change and new data pipelines will need to be implemented. Sometimes additional outputs are required from the model, and the interface to downstream operational systems is altered. In any event, the different iterations of the model will need to be version controlled, and downstream services will need to be amended if it is a major change. This process of developing, deploying, operating, and updating machine learning models is what we call MLOps. If you're interested in finding out more, please have a look at our EE playbook on MLOps, which you can find on the link here.